I am pleased to introduce our next speaker, Brad Jolliff and the law firm, who will be speaking on sample science for Artemis, collecting materials from the giant South Pole-Aitken Basin. Brad, you have 10 minutes starting now.
Thank you very much, Noah. And of course, who's the second author here? Yes, Noah Petro. Well, Jim, as usual, great context, and everything Jim said about sample mass, I will repeat here. I'm specifically interested in this talk about the possibility of sampling materials from South Pole-Aitken Basin. And so I'm going to take a slightly different approach to what Jim showed and back up a little bit and look at the compositional remote sensing that we have. Question is, how much South Pole-Aitken derived material will be there, and then how will we recognize it? So, science objectives associated with SPA Basin have been identified by the past two decadal surveys, and these objectives have to do with, number one, determining the basin chronology, and that is not just the age of SPA Basin itself, but the ages of the large craters and basins within it. This will constrain the period of late heavy bombardment on the moon, as well as models for the early migration of giant planets and other interesting early solar system phenomena. Also, number two, samples excavated by the SPA Basin may provide the first direct samples of the moon's mantle and new samples of its lower crust. Third, samples from SPA Basin will provide a test of models for giant impact basin formation applicable to all planetary bodies. Now, question is, at the Artemis landing site, and we're looking at the south circumpolar region here, will SPA-derived materials be needles in the haystack? I would argue that many samples would be needed to make statistical arguments to identify the materials needed to determine the chronology of the basin and find deep crustal and mantle-derived materials. So, picture's worth 1,000 words. Here is the Lunar Prospector Gamma Ray Spectrometer FEO map to a half-degree per pixel resolution, overlain on the LROC WAC mosaic. What you see is at the top part, that's the far side, southern far side, South Pole-Aitken Basin. In the middle is the south circumpolar region, southward of 84 degrees south latitude. And then at the bottom of the image is the southern near side feldspathic highlands. Well, a casual look at the south circumpolar region would suggest that it looks like pretty feldspathic material, low iron contents. But the idea is that SPA Basin, as Jim said, has its southern rim pretty much right at the South Pole, and some of the massifs there, in fact, are basin rim massifs. And so what's the possibility that some of that material is actually in there? Let's take a closer look at the compositions. So a hypothesis and a test. Materials ejected from the South Pole-Aitken Basin along its southern rim were deposited within the south circumpolar region. Of course, that was over 4 billion years ago. So subsequent impact history and ballistic mixing of deposits have diluted the southern SPA rim deposits, but some portion of the SPA rim deposit substrate is still present in the south circumpolar region. And these materials ought to be found among comprehensive samples collected at the Artemis 3 landing site. So my test here is to use Lunar Prospector Gamma Ray Spectrometer compositional data to determine mixing proportions of these two main classes of material, SPA Basin materials and feldspathic highlands. And here we'll use the southern near side feldspathic highlands for the test. Now, a key concept is that of ballistic sedimentation. I show on the right-hand side a model from Larry Haskin from almost 20 years ago, where he made the argument that with ballistic sedimentation, you can begin with a substrate shown on the left-hand side here that's entirely SPA ejected deposited material, and then have many subsequent impacts that serve simply to mix materials in and dilute that substrate, but they don't eliminate it. And ballistic mixing makes it a deposit that's well mixed. This is not layering, this is percentage of materials. So there should still be SPA ejected materials there. Well, let's take a look at the iron. Here, I'm just going to simplify things by taking a traverse from A, from the south central portion of SPA, to B, southern near side feldspathic highlands. You can see the SPA materials are high in iron. There's the average. through the south circumpolar region, the FeO content decreases. There's the average. And then on the near side, it's still above the feldspathic highlands, but still decreasing. And then we get into the feldspathic highlands, which is lower. Now, if you do a simple mass balance model, what you find is that within the south circumpolar region, on average, taking the average compositions, there ought to be about 40% SPA material and 60% feldspathic highlands. Of course, SPA materials higher on the far side of the south circumpolar region, 55%, and lower on the near side, 27%. Okay, kind of interesting. Well, let's take all of the major elements and thorium from the lunar prospector gamma ray data, and we'll use 5-degree data here now because we've got other elements that come into play. And here you see thorium versus iron plus magnesium, same kind of deal. South Pole-Aitken Basin, higher thorium, high iron plus magnesium. Feldspathic highlands, low iron, low thorium, and south circumpolar region in between. Now, the way the data points, the averages are arranged here, you get the idea, plus the way the labels are arranged, that the SPA percentage is going to be about 20% on average and 80% feldspathic highlands. For the circumpolar region, far side, a little bit more, near side, a little bit less. Of course, with 5-degree per pixel data, that's not a whole lot of resolution. And so the resolution is not as good as it is with certainly the 1/2-degree iron data, but you get the same sense. So sort of conclusions, will there be SPA material and deposits at the south circumpolar region, poleward of 84 degrees south latitude? Yes, and a non-trivial amount, on the order of 20% or more on average. Of course, that'll be more on the far side part of the south circumpolar region, less on the near side part. Will this material be easy to find? Not necessarily. It'll require many samples, careful analysis, compositional analysis, age determinations, and these materials will likely be as or in complex breccias, like this beautiful Apollo 14, 14321. That's Big Bertha, the largest of the Apollo 14 samples, a beautiful breccia. And the SPA materials may indeed be things like clasts within a breccia like this. So stay tuned for Carly Peters' talk after mine. Sampling for Artemis 3 must include comprehensive samples, systematic kilogram plus regolith samples, and sieved or rake samples to concentrate and collect hundreds of small rock fragments and a few big ones. Artemis 3 astronauts, please bring us back some breccias like 14321. And finally, I'll just end with SPA science will be enhanced enormously by a separate robotic sample collection from the interior of South Pole-Aitken Basin. Thank you.
Thanks very much for that, Brad. We have 2 minutes now, and we have a question in the chat window from Carolyn Vanderboger. And so I will, unless you have it up, I will recite it to you. Brad.
I'm looking at it.
Okay.
Go ahead and read it, Noah.
Do you think you can get an SPA age from feldspathic basin impact melts derived from the crust that have been excavated, for example, taking the oldest radiometric age? Or would they be hard to separate from other feldspathic materials? Brad, the ball is in your court.
Well, yeah, okay. I'm not sure I quite follow, Carolyn. What we're looking for are mafic impact melts and mafic materials. And, you know, what I think we'll find are a lot of the mafic materials in the south circumpolar region that give us that SPA signature will be materials that have been excavated and possibly ages reset by other big craters. I mean, think about something like Antoniadi, but Antoniadi struck SPA basin substrate. And so the materials, and if there are, you know, clasts that retain zirconium phases or, you know, other phosphates, other ways of dating the materials, we'll be able to get those ages. And I think it's going to take a lot of analyses before we see that sort of bookend of South Pole-Aitken Basin age. I'm not sure that answers your question because you're asking about feldspathic materials, and I'll be more interested in the mafic materials.
All right, we need to move on.